Hi everyone, this is Graham at ZTech Inside. I'm just going to show you how to reset the ECU for the calibration for the new engine coolant pressure sensor that we need to set up. We've also got to reassign the I/O, so that we're going to disconnect the two dampers for the rear, and we're going to reassign one of the two analog inputs that's then free to the engine coolant pressure sensor. So we've got LifeCAL open. I'm going to do a device and then connect. It's going to search the network for the device. I'm going to click OK. It's now going to open up the calibration. This is live now, connected to the car. Just takes a second. Here we go. Right, so we need to go down to I/O configuration, pin assignments, and then go down to where it says damper position rear left wheel. That's analog input number 9 from the X10, which is the slave device. So we're just going to double click on that. Press return. It now says it's not connected, so it's unassigned it. I'm going to do the same for the rear right wheel because I'm not using these sensors anymore, and that's now also says not connected. If I now go down to the engine coolant pressure sensor, double click, I know it's analog 10 and we've reassigned it. If I now do a device and then a program, it'll now send that calibration to the car, to the ECU, and it'll say it's finished. There it is, done. Okay, and we've got no errors. If we had the wrong analog input, it will be showing errors on the device. So I can press escape now, and we can go up to sensors. We can go to define sensors and trips, find engine coolant pressure sensor, which it can now see. I'm going to do a gauge add actually before we start. Gauge add, engine coolant pressure sensor. I'm going to put the sensor and the sensor voltage. Okay, we'll do text. We'll do 20 Hertz. That's currently showing you the pressure that it currently thinks is being seen by the sensor. Now I've got an absolute pressure sensor, not a relative one. A relative one or a gauge sensor starts at 0. The absolute pressure sensor that I've got starts at ambient air pressure, so it's 14.5 psi. The reason I've got an absolute one is I can't get a relative one at the moment. It'd be easier if it just started at 0 psi when the engine wasn't running, but this will start at 14.5 psi, which is approximately 1,000 millibars. It's not a problem. We'll sort that out into the linearisation. So if we go into linearisation, it currently shows a linearisation curve which is wrong. What we need to do is we need to flatten that out as zeros and then actually put the correct data in. So we do that by doing S and then A. That's selected all of the values in the table. Press return, press 0, and it's flattened it out. What we now need to do is we need to say that when it's showing 4.5 volts, it's 100 psi. So I'm going to press return, type in 100, and then I'm going to select the cells all the way back to 0.45, which is the lowest voltage that you'll see. So it'll return between 0.5 volts and 4.5 volts, and that represents 0 psi to 100 psi. So what we're doing here is we're just linearizing the table by using something called interpolation. So I press M for math, I for interpolate, and then X for X axis, and it's now put the gradients in. So that's actually right. So it's now showing engine coolant pressure down here as about 15 psi. So 14.5 is actually 1,000 millibar. So it's almost perfect. So what we'll do now we've linearized it, I'll press escape, device and program. It's going to write that back to the ECU. There you go, calibration flash program is successful. Okay, so that's now done now. That's now ready to be used. One thing we do need to do is go into default sensor reading. So if there's a problem with the ECU and it loses the connection from the sensor, at the moment it'll just return the 0 psi. We actually want that to be 15 psi. We'll go for 14.5. So if it ever disconnects itself from the sensor or there's a fault, the default reading will now be 14.5 psi. So hopefully the engine will carry on running. It's not going to suddenly think there's a huge reading or a very, very low reading and then cause it to trip. So again, we'll do a device program. Just wait a second for for it to send that across the network to the device. There we go, that's done. There we go. Right, so escape out of that. So that is it, that's done, that is now calibrated. We just need to go over here into the config software and get the config. This is the logging information for the ECU. It's logging sensors for the dampers, which we don't want to log anymore. So we're just going to go in here and we're going to turn that off. So if we go view and then look at logged, which is VL, and then scroll down here, we've actually got, it should be right rear and right left damper. So right left, right rear damper, there's the right rear damper. So it's currently showing 0. Let's just go tab across, that's 100 times a second. So I'm going to set all these to 0. Right rear damper, that one there's a 0. I just press return twice, it clears it. And then we want rear and left damper, which is that one there, so 0. That was taking up quite a bit of memory because it's recording the damper positions for both those dampers at 100 times a second. So that's now off. What we do need to do now is actually add engine coolant pressure sensor. So if we go down to ECP, so if we do view and then do all, it'll bring it back to show all of the channels that we can log, and we'll go to ECP, which is going to be engine coolant pressure, that one there, and we want it to log it. It's analog, it's not going to move very rapidly, so I mean 5 Hertz is more than enough. So I think we'll just leave it at 5, and it'll then log at 5 Hertz for all of the different situations that the engine's in. All these different conditions determine the sample frequency. So for example, while traction control is in operation, there's traction events happening, you can get it to log at say 100 times a second. Not that you'd want to, but that will now log engine coolant pressure 100 times a second. Just going to blank that back out again. So that's done. So what we'll do now is we'll just do a device and set config. It might warn me it's going to lose the data if there is any in the ECU. We do an OK. And it says, do you want to delete the session data? Yes, please. And that is it. So I'll just do a quick save. The last time I did that was September, so December the 19th. Can't spell, December the 19th. Okay, that's that done. Then we'll just go back over to the calibration. We'll save that as well. That should be the 19th. 1219, I'll call it B for Bertie. Okay, right, that's just saving that now. Right, so we're done. So the ECU is recalibrated. It's now showing the correct engine coolant pressure for a absolute sensor. Don't forget, absolute sensor shows atmospheric pressure when there's no pressure inside the coolant system. That's quite normal. What I will need to do is at some point go into engine trip and then set up these settings here for how I want the ECU to react. If it's over temperature, pressure, sorry, or under pressure, I can get it to stop the engine or go into limp mode. And then on here we can also determine the number of times it ignores the trip. There's quite a lot of very clever sensor settings in here. I'm just going to leave those for the time being. We need to run the engine and then monitor the engine coolant pressure. Once we've got that recorded, and I've got probably 2 or 3 events worth of data, and I can then come into the engine trip section here and set it up to determine what I want it to actually do if the pressure is different to what it should be. Right, that is it for now. Thank you for watching. Please like and subscribe, and I'll be posting more updates later.